Have you ever wished you had superpowers, like maybe X-ray vision? Well, today we're talking about a technology that's pretty darn close. It lets us see our planet in a completely new way, a way that works without any light at all. It's how we can watch the Earth change, day or night, rain or shine.
I mean, think about it. The cameras on satellites, as powerful as they are basically just like the camera on your phone. If it's dark, you get nothing. If it's cloudy, well, you get a great picture of clouds. So how do we get that consistent 24/7 view of what's really happening on the ground?
Well, the answer is to stop looking for light and instead to make our own. We have to use a completely different way of seeing, one that plays by a totally different set of rules.
And this right here is the heart of it. On the left, you've got your passive sensors. That's just a fancy word for a regular camera. It waits for sunlight to bounce off something and it captures that reflection. No sun, no clouds in the way, no picture. But on the right, that's where the magic happens. Active sensors are like a camera with its own ridiculously powerful flash. They don't wait for light, they create their own pulse of energy. That means they work anytime, anywhere.
And that amazing active technology is called synthetic aperture radar, or SAR for short. Instead of light, it sends out a focused pulse of radar waves. Then, it just listens. It records the echo of that pulse as it bounces back from the Earth's surface. It's like it's painting the entire landscape with radar, and then building an incredibly detailed image from those echoes.
And this, right here, is SAR's superpower. Because it makes its own light and uses microwave signals that just don't care about clouds or fog or smoke, it gives us an all-access, all-weather pass to see our planet. For SAR, it's always a clear day.
So how in the world do you turn a bunch of invisible echoes into a high-resolution image? It sounds like something out of science fiction, but the process is actually pretty straightforward and really, really clever.
Okay, it breaks down into these 4 simple steps. Step 1, the satellite fires off a radar pulse. 2, that signal travels down and hits the surface, a building, a tree, a field, whatever. 3, the satellite sensor catches the echo that bounces back up. And finally, step 4, and this is the key, a computer on board measures exactly how long each echo took to return and how strong it was. From that timing and strength data, it builds a complete picture, pixel by pixel.
But here's where it gets even smarter. The way that echo bounces back tells us a ton about what it hit. It's called scattering. So if the pulse hits a rough field, it scatters everywhere, creating a kind of gray, textured look. If it hits a forest, the signal actually goes into the canopy and bounces around a bunch before coming out. That's volume scattering. But if it hits a city, you get this super bright signal called a double bounce, where the pulse hits the side of a building, bounces to the street, and then zings right back to the satellite. It's these different signatures that let us distinguish a city block from a dense forest.
And get this, we can even change the radar's wavelength to see different things. It's like switching between different types of vision. A shorter wavelength, like C-band, pretty much just skims the surface of a forest canopy. But a longer L-band wavelength can push right through the leaves and branches to see what's underneath, bouncing off the tree trunks and the forest floor. So at the flick of a switch, we can get 2 completely different views of the same exact spot.
Okay, so this technology is obviously super cool, but what does it actually mean for us? Why is having this all-weather superpower so important in the real world?
Well, it means a lot. SAR is sensitive to water, so we can track soil moisture to help farmers grow more food. When a hurricane hits, we can see right through the storm clouds to map the flooding in real time for rescue teams. We can monitor illegal deforestation in places like the Amazon, which are almost constantly covered in clouds. We can even spot tiny millimeter-level sinking in the ground that might warn us if a bridge or a dam is in danger. It's a total game changer for monitoring our planet.
And the level of detail we're talking about is just incredible. Modern SAR satellites can see objects on the ground that are just 1 or 2 meters across. That is sharp enough to clearly make out individual buildings, roads, and even see what's happening in specific parts of a farm field. The precision is just astounding.
So, as you can probably tell, this isn't just some niche scientific tool anymore. SAR is quickly becoming a cornerstone of how we understand our planet, especially now in the age of AI and big data.
And here's why. AI models need one thing to learn: tons and tons of consistent, reliable data. And SAR delivers exactly that. It provides a constant, uninterrupted stream of images, what scientists call a satellite image time series. You can feed this reliable data stream into an AI, and it can learn to automatically spot patterns, classify land, and detect changes across huge areas, way faster than any human ever could. And this all-weather future is already here. This isn't just one satellite. We're talking about a whole fleet of them up there. Europe, Germany, Canada, Japan, Italy, they all have these incredible SAR missions flying right now, working together to build this massive, continuous data set of our changing world. So when you put it all together, it means that for the very first time in history, we basically have the ability to watch any spot on Earth all the time, no matter what. And that leaves us with a pretty big question, doesn't it? With this new, persistent, all-seeing eye, what will we choose to focus on? And more importantly, what will we do about what we see?